Hi, my name is Noah Gift, and what I'm going to show you today is how to take a function in Python, build it out in AWS Cloud 9, and then put it into a FastAPI microservice, push that into a container, then deploy that via AWS App Runner, then set up AWS Code build to do continuous delivery of that microservice. Okay, let's go ahead and get started. Let's talk through a source diagram here that shows how the source code, the runtime, all get put into the container. And this gives us both DevOps and MLOps based workflows. Really, this is why you would use a container. It enables continuous delivery. So next, let's go ahead and take a look at how we can do continuous delivery using containers by leveraging a service from AWS. So this service from AWS is called App Runner. And App Runner allows you to take containers, package them up, review them, and then build out secure URLs. So this is a really powerful workflow, and it definitely enables you to move very, very quickly. And what we're going to do is actually use this technology to deploy a containerized service. First, I'll build a Docker file, and this Docker file allows us to really package up everything, including the runtime, and put that into our code. So I'll go ahead and take some code from a previous project, paste it in. Here is the base image here. I'm using the AWS Lambda base image, which is a decent base image for me to use. And then I'm going to do some run commands that take a source code, which is main.py, and put it into the app directory. And then I'll go ahead and install the packages that are necessary, so that again, that packages the runtime together with the source code, and then that'll give me my microservice. So next up, I'll need to create this main file. And so this main file here, we'll go ahead and do a touch. And then again, I can just grab some code from a previous project and paste that in. It's just more of like the template. And this is a nice example here. I can just paste in. And once I go to the main file and I put it inside, what I'll do is just clean this up a little bit. So first step, what we can do is, take a look at some of the requirements as well. And these requirements will be helpful because I'll need to install the UVcorn and also the FastAPI inside of here. So we'll go ahead and do that so that we can actually test this thing out. We'll make a space here, and I'll pull out the ones that I've already installed, and we just have 2 left. Great. And then from here, I can do a make install, which will be nice because it makes it very simple to install packages. And we have a make install. Great. And then I think once I've installed this, it's going to be a good idea to pin the version numbers. So what I can do is run this command called pip freeze. And pip freeze will show me the current versions inside of my system. Here we go, pip freeze. And then I can actually go through and pipe that into less and just find the packages I care about, pin those in, and then go ahead and check that into my repository. All right, that looks good. We've got everything working here. And then I'll go ahead and say make install to just verify that those pinned versions work. They do. Great, so we're all set now to run FastAPI, and what I'll do to run FastAPI is just clean this up a little bit, remove some code, change things a little bit. So I'll say inside of here, a message at the default route here, the root hello functions from 0, and then I'll clean up this function so that it'll accept a fruit, and so I can do this by changing the route here. Instead of adding 2 numbers, we'll go ahead and we'll put fruit, and then I could pull out as well this bit of code and change it so it accepts a fruit parameter. Perfect, that looks good. And then I'll change the name of the function as well. We'll change that to let's say my fruit. That looks good. And then I'll also need to change the doc string here so that it has proper documentation. And we'll put a message here that says add a fruit to random fruits. Great. And then we can also go through here and test out as well the import of our library. So I can have a library that generates random fruit, and I used it in a command line tool, and I can just borrow some of that code and paste it in here. This looks good. Paste this in. And once I've got this running, notice that I am getting two warnings here. So undefined variable fruit, because I need to pass that into the function right here. So go ahead and do that. And then I'll need to change it to a string. That looks good. And once we've got this set up, then the error messages are almost gone, except for I need to return back a variable that I have already defined, not an undefined one. So we'll change this to random fruit, and I'll change this to chosen random fruit, which will be the value that's returned from my library code. Okay, great. And inside of here, I can just go through here and do Python main, and this will run this in foreground mode. Perfect. And we can see this URL. I can actually open up a new bash terminal, and inside this new bash terminal, I can do a curl at the default, and it says hello functions from 0 to. Perfect. And if I want to test out the fruit route, I'll pass in a fruit, and what it'll do is it'll take that fruit and append it to a list of other fruits, and then randomly choose the fruit from the list of fruits that it's generated. It looks like it's working. So we've got this thing running, which is great. So really the next step here is to kind of take this thing to the next level. And in order to do that, I'll just want to make sure everything's checked in, pass all this in, go ahead and commit this. Once these changes are committed, this will make sure our continuous integration server will be able to run it. It's always a good idea to have your continuous integration server running your code, constantly testing it to make sure it's good. So we got that going in the background. And then next up, what we can do is actually kind of build this out in a new environment and make sure that we're able to actually containerize this process. And so to do that, it's fortunately fairly straightforward. All I need to do is use these build steps. So I'll say Docker build, and I'll do space. So let's go ahead and do that. And this will just build a container locally inside my Cloud9 environment. And this is where having a very powerful machine can really make a big difference. The more powerful your machine is, the quicker it's going to build. So when you're building containers, it is good to pick a pretty powerful machine, lots of memory, storage space, and then also a fast disk. In this case, this is a larger Cloud9 environment, so it works pretty fast, and I'm able to actually get this thing built. Now, once I've built this, what I'll need to do is look at the ID for that image so that I can actually run it. And so I can do Docker image ls, and this will give us the ID, and you can see there it is. And so what we need to do is I can follow the command I have pasted in another project, essentially a Docker run command. So we can see that's a good Docker run command to use. And I can just kind of clear that out, replace the ID with the new ID, and we can go ahead and run the containerized version. So it will work literally identically to the previous version that I ran that wasn't in a container. So this really shows the power of a container, is that you can actually build things in a way that allows you to really replicate what would happen on your laptop, and it will identically replicate inside of a containerized environment. So great, we're ready to go here, and we've got this thing set up and containerized. So, what can we do now? Maybe add a little bit of documentation to make sure that this is inside of our project. It's always a good idea. And so let's go ahead and put this documentation inside of here. Great. Now, once I've got this, the next thing that I can do is paste in the Docker build command. There we go, Docker build dot, and then also that run command. That looks good. So really I've documented my project as well. Always a good idea to make sure that you're keeping track of the documentation, letting people know how to really build your project. And we can see here that I'm adding Docker instructions. That's great. And I'm going ahead and I'm pushing these changes. Perfect. And from here, what we can do is really move on to the next step here. Now that I've got this containerized, and I'm going to go to ECR, which is the Elastic Container Registry. And the Elastic Container Registry allows me to create a private repository to host my container. And this will later allow us to do continuous delivery with App Runner. First, we need to create the container. So I'll go ahead and build out a new repository name. And inside of here, we'll call this deploy FastAPI. Now that I've got that hooked up, we can actually take a look at what settings I want. I could, enable security scanning, encryption, etc. We're just going to create a default configuration. And then you can see I have a bunch of other repositories set up here, but we're going to use the deploy FastAPI repository. Now, how do I push things in? Fortunately, very straightforward. All I need to do is view push commands right here. Once I view the push commands, then I can actually just do those step by step. And it makes it very easy because there's a copy button here. And each time I want to deploy something, I just paste that command in. This authenticates me to the ECR. Great. Next step, I would go through and I would build it. And it's going to be tagged with a new name here, which is called deploy FastAPI. Perfect. Let's go ahead and do that. Let's build this out and give it this new name. So we see that we don't have that built here locally, right? And so I'm going to delete this other image just so I can keep my space under the size limits, because the Cloud9 environment, we want to make sure that it's really kept small. And so in this case, I've deleted my previously built container image, and I'll just go ahead and paste the image or paste the command to build the image here and build it again. But this is going to be the container image that will be pushed to the ECR repository. Okay, this looks good. Things are running successfully. And really the next step here would be to do the final tag that will be tagged into the repository remotely. And then I'll also go through here and then push it to the repository. So we need to tag it so we can push it to the repository. That's really a very quick command. And then we'll go through and we'll do a push, which takes a little bit longer, but because we're in Cloud9, which is co-located with other machines, it's going to be very fast. And this is really one of the advantages to building in the cloud, is because you're co-located next to other machines, your push of the container to the container registry is very, very fast. And this is a huge advantage over let's say, your local laptop and pushing a container over a slow wireless connection. So definitely important to use this capability. Okay, next up here, let's go ahead and move on and get past the checking of where the container is in the repo. You can see it's 234 megabytes in size, right? So we have successfully done one of the components of building continuous delivery with containers, which is getting this into the ECR, or the Elastic Container Registry. So next up now, what we need to do is head over to App Runner. So let's go over to App Runner here and set this up. Fortunately, it's very straightforward. First, you select create an App Runner service. Notice I'm going to select Container Registry, and this will allow us to use the Amazon ECR registry. And from there, I'll be able to click Browse, select down to the MLOps repo here that I created, which is the deploy FastAPI. And then from here, I can actually go through and select what kind of deployment I want to do. I can do manual, I can do automatic. I'm going to go ahead and select automatic. And now I can also go through here and select what kind of ECR access I want. And so because I've already created access before, I can just go ahead and use that service. If you haven't done it before, you can just create a new service. Great. Now I just need to name it something. So I'll go ahead and put a name in here for the service. We'll call this Containerized Fruit. Now, again, it could be MLOps, it could be DevOps, it could be Microservice, SaaS product, whatever it is. Because I've already set up port 8080 inside of my application, right? You can see I'm serving this out via 8080. If I look at the main file here, you can see that the application itself is on port 8080. And if I go to the Docker file, I also expose port 8080. So we've got really a link here so that this thing will run on port 8080. And the rest of those options I don't need to configure. All I need to do next here is scroll down, set up an automatic deployment, and go ahead and say create and deploy. Great. Now this is going to create this service. This will take just a second here, and we'll go ahead and let this thing run. Now, while it's running, what I'm going to do is I'm also going to go back to GitHub Codespaces, and I'm going to show how we can also test a containerized workflow in a totally different environment. So it'll take a second for the App Runner to deploy. So we might as well test out a different kind of workflow. I'm going to select container here, and I'm going to pull in the latest changes. There we go. And let's go ahead and also make sure that I can just build out containers inside of this environment. If I do make all, this will go through here and it will build out all of the latest updates, everything. And what's great about using a containerized workflow is that you can pretty much be assured that once you've got the container working, it would be easy to replicate this in a new environment. I can just either do a Docker pull or do a Docker build. In this case, I'll do a Docker build and build this container out locally and make sure that this container is able to run inside of this environment. So from here, if I scroll down here and I get into this application, we can see it's installing the software. It's getting this thing's cooking. Great. We got this thing, cooking inside of here. And once the container is built, I can do the similar process that I did before, which is to go through and find the ID of the container and then run that container and run it locally. So let's just give this a second here. Perfect. Now I can go ahead and run Docker image ls, and this will allow us to see the image of the ID of the image right here, and we see there it is, CFA 52. Perfect. And now I can just run that same command. I can say Docker run, put a space in there, find that image ID, and then go ahead and run it locally. So we're able to replicate this in multiple environments. We can see how powerful it is. Now, GitHub Codespaces has a nice little browser that we can view here, which will let us actually play around with the containerized application. And one of the nice things about this is that it allows us to test some of the UI elements of our application. And in particular, the UI element that's important here would be the Swagger documentation. That's something that comes with the environment. And so we'll go ahead and let this thing refresh here for a second. This will take just a second. We may have to kind of bootstrap it and try it again. But once we get this thing working, it'll allow us to double check. There we go. We see that the main route is successful. Now, if I just go ahead and I append a /doc to it, it will actually see the Swagger documentation. So let's go ahead and do that. There we go. Now inside of this Swagger documentation, I can try out my microservice. So let's go ahead and select it. Perfect. Try it out. In this case, I'll say maybe some name of a fruit. We'll say, in this case, cherry. Execute it. Perfect. We can see the curl response. We can see the response body. All of those things are available, and we can go ahead and execute pair, next thing. And all of these things are able to be really tried out from inside of this containerized microservice with API documentation. So that's really the big takeaway for using the Swagger documentation, is this nice interface here to play around with things. And we also can see the output running, which is incredible. All of this is really a powerful experience for us to to be able to test. Now that this is complete, most likely the AWS App Runner service is ready. Up, there we go, it's ready. So let's go ahead and now test the deployed service. And what's great about this is we can look at the logs. It says service status is set to running. If I select it, there we go. There's the main route, and I see that message. And if I append /docs to this, it will show us that the Swagger documentation also works right here, which is perfect. If you go through and you say get, and you say try it out, from here we can go ahead and say cherry, go ahead and say execute, and then from here we're able to respond back to the API calls, and we see all of the documentation for those API calls. So this is wonderful. We've got all this working, and we're able to respond to this web service and test it out. So that's really one of the advantages of the Swagger documentation that comes with FastAPI. So this is great, but what if I wanted to set up continuous delivery, right? Again, we'll go ahead and take a look at the docs here, the logs here that appear for CloudWatch. But in general, now that we got this thing working, I think the next step here is to get up working the continuous delivery process so that I can programmatically push this container into the ECR and then actually go and verify the results of that by doing continuous delivery. So really, having a continuous delivery based workflow by pushing new containers would be the next step. So let's go ahead and set that up. In order to do that, I'll go ahead and move on to building things inside of AWS Cloud Build. So let's go ahead and take a look at that. If you go back here, we can find AWS Cloud Build. And here we go, Cloud Build, perfect. Once I've got Code Build, once we've got Code Build working here, this will allow us to build out a new project. So we're going to first just get the basics working. And so I'll go ahead and I'll say, continuous delivery or something like that. Here we go, continuous delivery. And then I'll go ahead and create these different sections of the application. So in general, this AWS Code Build project is very useful because it allows us to build containers and push those containers. I like to do things incrementally though, which is start a little bit at a time. And so the first thing that I will do is that I will get this thing set up with just maybe testing the installation of our application. That should be relatively straightforward to do. And so in order to do that, I'll need to hook it up into our source code provider. That's would be this step right here. Next up, I'll go over to my repository in my GitHub account, go ahead and select that. And this should appear. Again, it'll allow us to pick functions from 0. Let's go ahead and find that. Let's scroll down here, functions from 0. And this should be coming up. Functions from 0 to, there we go, functions from 0 to, perfect. And then we can leave everything default here. If you needed to do advanced get options like submodules, you can actually do that. I've used that in other versions of my AWS Code Build. We'll want to rebuild every time a code change is pushed, which is nice. And then in addition, we'll want to go ahead and select a managed image. So essentially we'll want to pick the exact same environment that we're going to deploy to. So in order to do that, we want to select the operating system, which is Amazon Linux 2. Next, I'll go ahead and pick the latest runtime, standard and 3.0. And then we'll also want to enable the flag because we are going to build Docker images. So we do need to have elevated privileges, and we'll go ahead and select that. This is where it's easy to get tripped up. You want to have a role that has the privileges. I've already done this in the past. So I have a role here that is a service role that has the privileges necessary to speak to ECR. And then here is where we would want to insert our commands. So I'm going to click on insert commands. I'm going to switch to the editor. And this allows me to really just put Linux commands inside of here, and these Linux commands will let us test out the build process. So if we go through here and we build these commands together, I'm just going to take out this comment, and inside of here, I'm going to swap this out with a make command. And so I'll go ahead and say make install, and this will just really get the tires kicking, right? Like I'm going to go ahead and just, get the basics working here, and I'll go ahead and say create build, and then say start build. Perfect. And inside of this, we can actually go through here and do build logs next. And what will happen is that the build logs will show that this, if it's successful, will go ahead and install the software. So this is, I think, a good way to get started when you're trying a new build system that you've never tried before, especially doing something as sophisticated as continuous delivery of containers, is maybe do it in phases. So first try a little basic step. Now this also highlights how important it is to have a makefile, because if I didn't have this makefile, it potentially could be much more difficult to test my installation. Great, it works, awesome. So that's a great place to be. We know that it might work to get the push to the containerized environment. And so really all I would need to do is swap out that command with potentially something that does an installation, a lint, maybe a format of my code, all that kind of fancy stuff, and then goes through and builds out a container. And so how would we do this? Well, what we could do is we go back to our makefile here, and in fact, we would just add potentially a deploy step, which is pretty cool, because now we can actually set up continuous to delivery by just doing make deploy. Now, what would we put into the make deploy step? Well, we can go back to ECR, and we can look at the container registry. Inside of the container registry, we can find the repository. In this case, this is our deploy repository. Aha, here we go. We can find these commands. Let's put these in one by one. And this is the beauty of a makefile, right? Is I can actually just put these commands in step by step, right? The first step would be to authenticate to ECR. As long as the build system has the ability to do this, we're able to get past the phase one. Phase two is build the container. The build server will need to do that. The next step would be to tag it. The build server will need to do that. And then the next step, finally, will be able to push this container into ECR. There we go, Docker push, and this will push this into our ECR environment. And so if this is successful, because the App Runner environment has the ability to listen to ECR and do an auto deploy, this will set up auto deploy automatically. So this is an amazing workflow. And because we only need to push those changes, the make all will actually work. So I just need to add these changes to my project and add this deploy step, and then add at the very end here a deploy step. There we go. So I just say make all now. And if I do a make all, the deploy will automatically push a new container, which will then trigger the AWS App Runner deployment. So really an awesome workflow here. And let's go ahead and commit this change. So we'll go ahead and say, do our git commands here, git status, go ahead and add the new makefile change, go ahead and commit that change, and then go ahead and push this change. Because we've already told the build server to use the make all command, this will behind the scenes set up the final trigger to do continuous delivery. So very, very exciting. So if we go back now to our code build, we can look at it, and is it triggered? Yes. So this is triggered. Let's go ahead and look at the output of this. We can tail the logs. And so what will happen now, if things are successful, is it will go through and test it, lint it, format it, and push the build into ECR. Once this is successful, we can go back to App Runner. Aha, it was successful, and App Runner should have triggered. So let's first look at ECR here and double check the latest change. There we go. We have the latest change here, which is a new version of the container via continuous delivery. And now if we go over to App Runner, aha, it started the deployment. So we've got the full end-to-end workflow configured here. So really exciting, type of workflow to build things out. And this will take just a few minutes to get deploying. But once it's done, the way we'll test it out would be to go through and again call the same default domain URL and double check that our Swagger documentation works. And so let's go ahead and just make a quick sketch of everything that we built here and draw this out. So first up, let's go ahead and draw out the diagram of the process step by step. It really involves just a few things. First step, we would have to go through here and create a location. In this case, a location would be a cloud-based environment. In this case, it's Cloud9 where we do our development. Next, all we need is some kind of build system that has access to the container registry. There we go. We'll do that in code build. Next, what we need to do is take this code build environment and have the original source code get pulled in from GitHub. Now, it could be GitLab, it could be AWS code commit repo, it could be any repo. Once we've got this, it builds it, and then it does a container-based push over to our ECR environment, which is the Elastic Container Registry. Once it's in there, because we're using such a sophisticated microservice as App Runner, we can actually do full continuous delivery. What's beautiful about this is that this is really the basis for doing MLOps. It's the basis for doing DevOps. This is a foundational skill that everybody should have. And it fortunately is quite easy when you're dealing with both Python and AWS and you're developing in a cloud native way. That's the trick, is a cloud native way to develop software. And so what's amazing about this whole process is that it really is a very sophisticated yet relatively simple way to do continuous delivery, as long as you're using a full cloud native development environment with containers. So next up, what we should do is we should take a look at our deployed microservice and double check that it's able to deploy to production. I believe it should be pretty close now. If we scroll back over to the App Runner environment, and if we look at it, it looks like it's just finishing up. There we go. You can see it's now performing a health check, which it means it's very close. And if we go through and we just kind of toggle this by searching it, it's going to be able to show us each of the steps as it's finishing the deployment process. There we go. Health check is successful, routing traffic to the application. Now it's successfully routed incoming traffic to the application. Finally, when it goes green, we'll know that it'll be successfully deployed. There we go. Deployment completed successfully. Status is set to running. Awesome. It looks like we're ready to go. If I click on this link, we'll see that in fact it does work. And if I go to the documentation, great, we're able to actually get this thing running and verify that it works. We can even try it out, right? So continuous deployment, even though it is a very sophisticated technique, you can see here that it's actually relatively straightforward to set up if you use the right tools and the right techniques.